Not only do oblique drawings look kind of weird, you're actually going to draw them kind of weird too. Normally for orthographic projections, you're going to draw the easiest part, like visible horizontal and vertical surfaces first, and you would draw the hard parts like sloped, angled, diagonal surfaces or hidden surfaces last. But the special thing about oblique surfaces is that the shape will be visible from all three sides. And that means you should draw these first on your front view, top view, and right view. Then after you've drawn your oblique sections on all three views, then you go back and finish the orthographic projections by drawing all the horizontal, vertical, and all the other surfaces on the front view, top view, and right view. For this drawing, I've already drawn my bounding boxes for the front view, top view, and right view, so I already know where they will be. So I know that they're the right size and they're actually going to fit on my screen. So in order to draw this tall, skinny triangle, what I need to do is find the XYZ coordinate of all 3 points. And then I'll just plot these points, A, B, and C, on the front view, top view, and right side views. So once I have points A, B, and C plotted on each of the 3 views, I can just connect the dots and I'll get this triangle from all 3 different perspectives. So using my coordinate axes directions, point A is 0 in the X direction because it's right on the front surface, a distance of 4 over in the Y direction, and then a distance up of just 1 in the Z direction. So since the right side view is the XZ axis, point A will be at point 0, 1 on that drawing, where I'm measuring from the bottom left corner of the right side view because that's my origin on the isometric view. On the front view, my origin is on the bottom right-hand side. Again, it's the bottom front corner of the isometric view. And this front direction is the YZ axis, so point A is the Y and Z coordinate dimensions. Y equals 4, Z equals 1. The top view, looking from the top down, that's the XY axis, but where they're kind of flipped, where upwards is X, so X of 0, and then over Y of 4. And that's point A drawn on all 3 views. And by the way, this is your TA, Indiana. Indiana, say hi to all the students. He's cuddling up to the camera. That's a very friendly hi. Your TA, Indiana, is really happy to help you out with these oblique isometric orthographic drawings. So we repeat this for point B. Point B is still on the front face, so X of 0, but it's all the way on the left, so that's at Y of 6, and it's all the way up at the top, so Z of 4. So we plot point B on all 3 views. So point C is a little bit harder to see on the isometric view, so I drew some of these extra red lines to help visualize exactly where it's located. It's set back a distance 2 in the X direction, but it's at the same Y coordinate as point A, right? Y equals 4, and it's also at the very top of the shape. So same as point B, so it has a Z of 4. And once you've plotted A, B, C on the front, top, and right side views, connect all the dots and you've got 3 triangles that represent this triangular face from all 3 perspectives, front view, top view, right side view. And that's really cool. We were able to draw the oblique face first. We didn't have to draw all the rectangular, horizontal, and vertical sections in order to find where those points are. By defining yourself a coordinate system at the very beginning and finding the XYZ coordinates of each point, you can actually draw these shapes first. Because once you have all these diagonal lines in place, everything else is just going to be kind of finishing up. It'll be a lot easier. So we're getting all the hard work done at the beginning, and finishing the drawing will be really quick. Of course, there's a second oblique surface, so actually we have to do all this one more time. So if I define new points A, B, and C for this frontmost oblique triangle, point A is at coordinate 0, 2, 0. That's 0 in the X direction, 2 in the Y direction, but it's all the way on the ground, so 0 in the Z direction. Point B at 4, 2, 2, that is, it's set all the way towards the back, so X of 4, and then a Y of 2, and up just a little bit, not all the way to the top, just halfway, Z of 2. Point C at coordinate 4, 0, 0, since it's all the way at the back, that's X equals 4, but it's all the way on the right, that's Y equals 0, and all the way at the bottom, that's Z equals 0. Plot all 3 points using the right side view. We'll use the XZ coordinates. The front side view will use the YZ coordinates, and the top view, the X and Y coordinates. Once you've got all 9 points plotted, connect the dots, and you've got 3 brand new triangles representing this triangular oblique face from all 3 perspectives, front view, top view, right view. So now to finish the drawing, you're just going to use your regular procedure for vertical, horizontal, or diagonal faces. We're just going to focus on one view at a time, front, top, or right side view, and basically just start at the front and work our way towards the back, or top to bottom, or right to left. If you want some easier practice with just vertical and If you want a more beginner level refresher of how to draw front, top, and right side views, click on the video right up here that you'll see that's got just horizontal and vertical surfaces, and you can go back to see the very basics. So maybe open that up in a new tab and watch it after this one if you want some more kind of elementary review. But here I'm going to start off basically just drawing from front to back. So the first thing we've got is just this vertical trapezoid surface all the way on the left-hand side, and since I already have the diagonal line drawn, I'm just adding the vertical and horizontal missing pieces to finish this shape. This yellow highlighted sort of ramp shape right in the middle, when looking from the front, is just going to look like a rectangle, or in this case, a square. And for the front side view, that's it. You can see from this blue section that the rest of this sort of top right area is all just empty. It's all just a cutout that goes all the way through the part. So looking from the top down next, I can start again with this trapezoid shape that's all the way on the top left side. It's just flat on the top surface. And since I already have that diagonal line drawn, since I did the oblique surface first, I can just finish with vertical and horizontal lines to finish drawing this shape. That highlighted inclined face that's right in the middle, it was really short on the front view, but looking from the top, it's going to span the entire width of the top view, the entire height of the top view. And the bottom right-hand side, I'm just going to leave that empty because on the isometric view, you can see that that section is completely cut out, right? There's no material there. And looking at the whole view, there's nothing obscured, like there's nothing underneath something else that would be shown as a hidden line when looking from the top. Right side view, there's actually only one thing missing, is this blue oddly shaped section kind of in the middle. But again, since I drew the oblique lines first, all these complicated diagonal lines are already in place. So all I have to do is draw the horizontal and vertical connectors and the shape is done. So erase the rest of your bounding box and any construction lines or anything that you had, and this is your final drawing. So drawing the hard part first, the oblique surfaces that are visible on all three views by using an XYZ three-dimensional coordinate system, makes finishing the drawing super easy since you'll already have all of those complicated parts drawn and you can just finish up with the easy parts last. My hope is that you now realize that orthographic projections of engineering drawings with oblique surfaces are actually a little bit easier than you might have thought they would have been. Think maybe that's it? Maybe that's it. All right, I think maybe that's it.